Assalamualaikum warahmatullahi wabarakatuh. My name is Izamir Abdullah. So I would like to present for the introduction. So in this project, we required to do a simple FM receiver. So we had set our frequency after our discussion. We set our frequency at 93.0 FM. So we in this project also we should design a PCB by using software. After the PCB is designed, it will be fabricated out physically. The PCB will be drilled and soldered with the lamp elements, the resistor, diode, and we can get the prototype of the PCB. So the prototype, every time whether it will receive the frequency that we set, the prototype will be using only 9-volt battery. Okay, so for the aim of this project is to analyze the frequency modulation FM technique for the electronic communication system, to construct a report and conduct a demonstration in work related to the design of FM receiver, to practice professionalism in report writing and project demonstration. For the objective is to learn how to apply the theoretical knowledge to the practical design of 93 FM receiver, to learn how to design a suitable circuit layout for 93 FM receiver, to learn the method of conversion circuit layout on the PCB, and to get analysis from the result of practical design of 93 FM. The scope of the project is the FM receiver band that we choose should be in the range of 88 MHz to 108 MHz. The FM receiver band that we choose should be near the radio transmitter to enable it receive the signal strongly. IC cannot be used in the 93 FM.
I will present the methodology. First one, we need to fabricate the PCB of the 93 FM receiver, which can receive the desired signal from the radio station. Below are the diagrams that show us the step of our FM receiver PCB to fabricate it. The first one, we need to circuit design. The second one is simulate the circuit, and then we need to online booking our elements such as the inductor, capacitor, transistor, that's like this. And then the next one, we need to test our circuit on the breadboard, and then after testing we need to print our layout of PCB circuit, and then the last one we need to solder our circuit on the PCB. Then the first one, we need to use our software, which is the Proteus, to design the circuit and then stimulate it. After stimulate, we need to get the frequency waveform from the output, and then so we can online booking which element we need from the lab. And then after stimulation is done, we use the transistor, capacitor, inductor, resistor, battery, speaker, and our IC to connect.
So this is our circuit, our radio prototype. We use this PCB board to assemble our circuit. So as you can see here, the components we use in the simulation, we assemble it on the PCB board. Here's the output, the speaker. And now for the demonstration, I'm going to connect this circuit to our power supply. That is the 9-volt battery. So here you go. As you can hear, there is some hiss sound. because maybe this room is not very strong in this radio frequency, that is the 93 megahertz FM. So this is what we obtained.
I'm going to discuss about the analysis. In this project, we have used a different circuit which is better than the previous circuit. By using the protein software, the maximum we need to set frequency which is 12 megahertz. This is quite far from our targeting frequency which is 93.0 megahertz. We already done our PCB circuit, and the circuit is managed to form an input waveform from oscilloscope which is sine wave. We replace the antenna with signal generator as in the Proteus software because the antenna couldn't be defined. And moreover, the NPN transistor is connected to other NPN transistor because based on the NPN circuit, the base is our input and the emitter is tied to a constant voltage. The output is high and the transistor connected to the load and grounded. Amplifier LM386 is used to the integrated circuit which containing a low voltage audio amplifier. The capacitor and the resistor is connected as series and connected to ground right after the output is a type compensation, which is to keep the amplifier from oscillating. The capacitor is connected in series with the speaker just to determine the desired frequency response and the speaker's rated impedance. Thank you.
My name is Muhammad Daniel. Today I will present about discussion. In our circuit, we set the value of variable capacitor to 2.93 picofarad, and the value of inductor is equal to 1 microhenry. Then if we want to find the frequency that we want of our FM receiver, we can put into the formula. We calculate, then we will get that is our frequency 93 megahertz. So by this formula we can also get another frequency by only tuning the variable capacitor and the inductor. So thank you. For the conclusion, we can conclude that this project is indeed suitable for electronic students, especially to the student that taking up FM transmission and reception in their electronic communication theory. Through this project, we cannot apply our theory on some practical skill to do this project, such as soldering the circuit on PCB. After that, we can be able to calculate the exact value of capacitor and transistor to get our frequency. We also increase our teamwork after our finish our prototype of simple FM receiver. This FM receiver we do without an IC, but if this prototype want to be perfect and the effectiveness want to be good, we can use IC to increase the effectiveness, such as another example of IC that is TD7000.